Alright, so this is the last page in the notes on Lewis dot structures for covalent compounds. In this case, we're going to have to decide what the central atom is sometimes. This one's not too hard. Let's start first, before we get into the skeleton, by figuring out how many electrons we have to work with. So we start with our valence electrons. Nitrogen is in group 15, so it's got 5 valence electrons. Multiplied by 2, we end up with 10 valence electrons to work with. I'm going to put 2 nitrogen atoms because this is N2. I don't need to worry about the central atom or outer atoms because it's just 2 atoms connected by a line. That's our skeleton. Okay. Then we want to go to the outside, which again doesn't really matter which one yet. We're going to end up using all 10 electrons. So we have 2, 4, 6, 8. Okay, now I've used all 10 electrons. We want to ask if everyone is happy. Nitrogen on the left has 2, 4, 6 valence electrons. That's not enough. Nitrogen on the right has 2, 4, 6 electrons. That's not enough. So they're both unsatisfied. What we can do is take a couple electrons, let's take these 2, and share them down there to make a triple bond and see if that helps. Or make a double bond. Start with a double bond. Okay, now when I did that, it made this one happy, but not this one. See, I've got 2, 4, 6 on the left. On the right, I've got 2, 4, 6, 8. So this nitrogen is now happy. This one isn't. So this is when we would take another pair of electrons, and we're going to take them from the happy atom and share them and make, as I'd said before by mistake, make a triple bond right here. And we can check to make sure everyone's happy. This nitrogen on the left has 2, 4, 6, 8 electrons, and the one on the right has 2, 4, 6, 8 electrons. That's our final structure. All right, let's look at OH minus. Oxygen has 6 valence electrons. Hydrogen has 1 valence electron. And because it's got a -1 charge, that means I have extra electrons. I have 1 extra electron, so I add 1. 6 plus 1 plus 1 gives us a total of 8. I have oxygen and hydrogen. It's an ion, so I've got to put it in brackets. You can do this at the end if you'd rather. And put the charge negative, or you could put -1, or you put 1 minus. Any of those would be fine. Okay. Next thing we're going to do is connect these with a line. That's our skeleton step. Then we want to take care of the outsiders. We want to give all of the outsiders an octet. Well, hydrogen, remember, it's an exception to the octet rule. It only wants 2 valence electrons, and it already has 2, so I'm not going to put any additional electrons on hydrogen. But oxygen could use some more. It has 2, and it wants 8. Well, let's see, 2, 4, 6, 8. And by the way, that's the exact number of electrons I had available. Oxygen's happy, hydrogen's happy. We took care of the brackets and the charge. This is the complete structure of OH minus, which is the hydroxide ion. Look at CH4. 4 valence electrons for carbon, plus 1 for each hydrogen, multiplied by 4, because of the subscript. 4 plus 4 is 8. Put carbon in the middle because it's our singleton. There's only 1 of them. So I'm going to put carbon in the middle, and I'm going to put the 4 hydrogens around it. 1, 2, 3, 4. Then we're going to connect each hydrogen to the central atom with a single bond. Count as we go. 2, 4, 6, 8. All right, I used all of my electrons. Just check to make sure everyone's happy. Each hydrogen wants 2, and each hydrogen has 2. And carbon has 8 valence electrons around it. Everyone's happy. This is our structure. Let's go to the next one. NCl3. All right. Nitrogen has 5 valence electrons. Chlorine has 7. And there are 3 chlorine atoms. So 7 times 3 is 21, plus 5 is 26. 26 valence electrons. Nitrogen, since there's only one of them, goes in the middle. Then I have 3 chlorine atoms. We're going to put one here, and one here. Okay. Connect them with lines. 1, 2, 3. Each of those is 2, so that's 6 valence electrons. All right. That's our skeleton. Now let's look at the outsiders. Our outsiders are chlorine. They each want 8 valence electrons. We're going to keep going until we get to 26, trying to make everyone happy. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Oh, I've still got 2 more. I have 2 leftovers. So after we take care of the outsiders, the next step is leftovers. Leftovers go on the middle. I have 2 leftover. That gets us to 26. Now we want to check to make sure everyone's happy. Nitrogen has 2, 4, 6, 8, and each chlorine has 2, 4, 6, 8. Yes, everyone's happy. Let's go on to SO2. Sulfur has 6, oxygen has 6, and we're multiplying by 2. By the way, if you're a little rusty or if you haven't quite picked up on it yet, I'm just looking at the group number, and that tells me how many valence electrons it has. Sulfur and oxygen are both in group 16, which has 6 valence electrons. This is 18 when you do the math. Sulfur is the singleton, so it goes in the middle, and I have 2 oxygens. So those go on the outside. Start with a single bond to each. That's our skeleton. All right, that was 2, 4. I've got 18 to use. 2, 4, 6, 8, 10, 12, 14, 16, and 18. Okay, so I got 16 with the outsiders, and remember, leftovers go on the central atom. So that's what we did. The next step is we ask, is everyone happy? Well, oxygen is 2, 4, 6, 8, 2, 4, 6, 8, but sulfur only has 6 valence electrons. So you can choose either this oxygen or this oxygen. We're going to take away 2 of its dots and trade them in for a shared pair of electrons in a line. Now let's check. 2, 4, 6, 8. That one's happy. 2, 4, 6, 8. Sulfur's happy. 2, 4, 6, 8. And oxygen is also happy. We're done with that. XEF2. Now this is one that a lot of students get. A lot of times I get the question, wait a second, xenon is a noble gas. How does Xe react? Well, fluorine is highly reactive. Xenon tends to be unreactive because it's a noble gas, but there are exceptions to things in chemistry. So they use the correct conditions. They can actually force the noble gases that are down in the last few rows of the periodic table into reacting, as long as they do that with a really reactive gas like fluorine. Anyways, so xenon has 8 valence electrons because it's in group 18. Fluorine has 7 valence electrons, and we're multiplying that by 2. So we end up with 7 times 2 is 14. Add 8, you get 22. Xenon goes in the middle. So there's only one of them, and then we have 2 fluorines. Kind of an interesting looking molecule when we draw it. Okay, so the skeleton, connect them with a single bond. All right, and I need to get to 22. I've only got 4 there. 2, 4, 6, 8, 10, 12, 14, 16. We always make the outsiders happy first. So we got to 16. Now, all of the leftovers go on the central atom, and because xenon is down in the 4th period or lower, it can actually accommodate extra electrons. This is going to be an expanded octet. So I just used 2, 4, 6, 8, 10, 12, 14, 16. Now I'm going to go 18, 20, 22. And I know that looks weird and it goes against the normal octet rule. But there's nowhere else I can put those electrons. I've already taken care of the outsiders, so the extra electrons, even if it's too many, go on the central atom, like this. So this is an expanded octet. Let's look at BH3. All right. Boron has 3 valence electrons. Hydrogen has 1 each, and there are 3 of them. So 3 plus 3 gives us 6 valence electrons. That's how many I can use, and I have to use them all. Okay, so boron goes in the middle. We have 3 hydrogens. Start with a single bond. 2, 4, 6. Now wait a second, it looks like I used all of those up. Can I do that? Well, don't forget we've got those exceptions. Hydrogen is an exception that wants 2 valence electrons. Beryllium wants 4, and boron is another exception. It wants 6 valence electrons instead of 8. So this is the correct structure for BH3. Everyone's happy. Let's look at PCl5. That already sounds weird. Phosphorus has 5 valence electrons. Chlorine has 7 multiplied by 5. 35 plus 5, that gives us 40. Phosphorus is going to go in the middle, and I need to draw 5 chlorines around it. Normally we only have about 4. Well, this time we've got some extras, so we're going to draw 5 chlorines. Try to kind of spread them out. You could draw it some other way if you want to. We're going to connect each chlorine to the central atom. 2, 4, 6, 8, 10. I've got to get to 40, so that's 10. 12, 14, 16, 18, 20, 22, 4, 26, 28, 30, 32, 4, 36, 38, and 40. All right, all of the chlorines are happy, so we worked on the outsiders first. And then you see that phosphorus has 2, 4, 6, 8, 10. It's got too many electrons, but there's nothing else we can do with this. This is another example of an expanded octet. And that's always the central atom that gets the expanded octet. Now we get to ClF3. Chlorine has 7 valence electrons. Fluorine has 7 valence electrons, but there are 3 of them. So that's 21 plus 7 is 28. Chlorine goes in the middle. I have 3 fluorines. 28 valence electrons. Let's start by finishing our skeleton. 2, 4, 6. Go to the outsiders. 8, 10, 12, 14, 16, 18, 20, 22, 24. Got a couple more pairs left, so they go in the central atom. 24, 26, and then 28. Yes, chlorine has more than 8 valence electrons, but that's all we can do with this. So we've got 2, 4, 6, 8 for each of the fluorines, and chlorine has 2, 4, 6, 8, 10. Again, the central atom can have extra valence electrons sometimes. It shouldn't have too few, but it can have extra. So chlorine is another, or ClF3 is another example of an expanded octet. So we did 3 expanded octet examples. All right, you should be able to work through the worksheet now. Let me know if you have any questions.